So it's important to be able to do this because only soluble ionic or acidic compounds have Van't Hoff factors, that's that letter I, larger than 1. So if you can't determine whether you have an acidic, ionic, or molecular covalent compound, you can't tell what the Van't Hoff factor is. And you need to be able to do that. Some examples. HBr, you should know from the formula that this is an acid. And you should know from the fact that this H is on the front. Other than water, almost any compound with H on the front is going to be an acid. Acids do dissociate, break up in water, so this would form a Van't Hoff factor in water of 2. This formula was formed from one hydrogen ion and one bromide ion. That's 2 ionic particles, so I is going to equal 2 here. And you know that it can dissolve and break up because it's acidic. Alright? If I have magnesium sulfate, you need to know that's ionic. You can tell it's ionic because you've got more than 2 elements in the formula, and you can look on your test references. Zach and Ryan, this is important up here. Jonathan, this is important up here. Kenya, this is important up here. Kenya. Kenya. Kenya, you can go drink water. Go get a drink of water. Yeah. No, we drink water. Okay. Nate, get up. Nate! Nate, wake up. Go get a drink of water, Kenny. Can you drink of water, Nate? Well, you're not allowed to go back to sleep, so sit up, please. You don't need a bathroom pass to get a drink of water. Apparently. All right. Actually, you know what? That's the wrong formula. It's just MgSO4. Okay. Now, there's a polyatomic ion here. That's your clue that you've got an ionic compound. This is made of magnesium. Ionic compounds are going to have charged particles, so this magnesium has a 2+. You can find that from the periodic table with oxidation numbers. Sulfate has a 2 negative charge. You can find that on the common ions list in your test references. So we've got 1 of each of those, and I here is going to equal 2 as well. Okay? If I give you a name, well, let's see. Let's do one other compound. Let's do Na2S. Okay? You need to know if it's ionic, acidic, or molecular. We have a metal combined with a nonmetal. That means this is ionic. Ionic compounds can dissolve in water. You look on the solubility rules to know for sure. This one does. It's made of 2 sodium ions and one sulfide ion with a 2 negative charge. Those charges you can find on the periodic table with oxidation numbers in your test references. That's a total of 3 particles. Okay? Okay, here's the name. You need to be able to look at the name and figure out the formula, and from the formula figure out what I is going to be. You can't figure out the formula unless you know from the name what kind of compound it is. Molecular, ionic, or acidic. It's ionic. Both of these parts of the word are not found on your periodic table. Both of these are found on the common ions list. That means both parts are polyatomic ions, and this is an ionic compound. Ammonium on your common ions list is NH4 with a plus charge. Nitrate on your common ions list is NO3 with a 1 negative charge. You need to balance this formula, and you should be able to see you've got a 1 plus charge here, a 1 negative charge here, and that's when you put those together, the compound is going to have a zero charge with just one of each. So the formula is NH4NO3, and I is equal to 2. 2 particles, I equals 2.
I thought you added the numbers up when you got the end of the problem.
What now?
I thought you added the numbers up when you got the end of the problem.
How you figure it out is not, whether it's at the end or at the beginning, doesn't really matter. You have to know whether or not what I is going to be. Okay? No, it's not going to be 7. Okay, I understand. It's not the number of atoms, it's the number of particles. Okay? That it breaks up into in solution. Back in Unit 5, when we were learning to write ionic equations, we learned that ions break up in water. Other things don't. So the hydrogen ion from a water and the bromide ion from this particular acid break up in water. The magnesium and sulfate break up in water. The ammonium and nitrate break up in water. Okay? So what kind of a compound is this? Is it molecular, ionic, or acidic?
Molecular.
Okay, I heard acidic and I heard molecular. Why would you think it's acidic?
Because it has
Hydrogens have to be on the front for it to be acidic. Okay, is it ionic? Why would you think it's ionic? Okay, you might think that this is an hydroxide. However, for it to be hydroxide, this also has to be a charged particle, right? Because both of these have to be charged to be ionic. Can you find CH3 on your common ions list? It's not there. This is molecular. Okay? We looked at these kinds of compounds and these kinds of formulas in the last unit and said these were molecules. Okay? This is a hydrocarbon with an OH group attached to it. OH groups attached to a hydrocarbon is not ionic. It's covalent. It's a molecule. So if this is a molecule, what is I going to equal? 1. Okay? And those are the kinds of interpretations you're going to have to make on this test to be successful. Okay? Any questions about that? Anybody, you need me to give you more? You want me to give you more examples? Yeah? All right. I'm going to give you a few for you to work on then. Mm-hmm.